Thank you for being here. Just a reminder, we're going to be talking about page 308 in this video, and page 308 is a continuation of the alternate interior angles theorem. I really recommend that you have your pile of note cards, but that you'll see what I do in this video. I'm going to go ahead and sort those note cards, or they're pre-sorted right now, to match the different statements that are on page 307. So specifically, go ahead and have access to, let me go ahead and bring this up, have access to your given card, same side interior angles, linear pair, definition of supplementary angles, substitution property, there's a lot, corresponding angles theorem, vertical angle theorem, and transitive property. The other note cards that we've been making along the way, they're good. They're part of the different things that you need to know for geometry, like reflexive property, etc. However, for this video, and for page 308, we're just specifically trying to match the reasons that Abellina and Madison use in their paragraph proofs. Okay, so I've got a ton of different highlighting going on page 307, a lot of good processing of that page. If you haven't processed page 307, please go back and do that. By process, I mean highlight with several different layers of highlighting. Because as we see an example from someone, myself or another student, and we're critiquing the reasoning of others, we need to be able to also process what they said and then turn that into actionable statements. Like number one, list the definitions, postulates, and theorems Abellina and Madison used in their proof plans. And so in order to do that, let's go ahead and just focus on Abellina first. Bring my face back in and zoom in a little bit, or set it to the side. Okay. Abellina used several different statements along the way. And so first of all, let's acknowledge that it's there. She might not have specifically said it, but she had a given. She was using what was given to us in the original part of the problem, and she focused on W is parallel to X. I can see that, alternate interior angles. I can see that in how W and X being parallel and Z being a transversal allowed us to set up some of the relationships that yet. So she had a given statement. I didn't want to jot that down, so I'll leave the cards up here, but know that on the side, I'm writing down Abellina. Here, I'll show you the setup, and then I'm going to move my page to the side. Abellina, she used the given, and then I'm going to start making a list here. So I'm going to do that off camera, but you're going to see the cards that I'm doing in the front. Okay, next up in the list, she says something about supplementary, and then she says, here's my pink statement. You know, I'm looking for the becauses in her paragraph proof. She says, same side interior angles theorem. So I'm going to add that to my list on page 308. Same side interior angles. These are the reasons that she is able to come up with her statement that angle 4 and angle 5 have the same measure. Okay, let's keep going. Angle 5 and angle 6 are supplementary, and that is using the statement they are a linear pair. So I'm going to bring out the linear pair card and add that to the list of theorems, statements, postulates that Abellina used. Linear pair postulate. And then I'm continuing to look a little further on down the line. It shows, let's see, she also used definition of supplementary angles. All right, so I kind of see supplementary here where she brings together supplementary, and the fact that supplementary means they add up to 180. So that's another thing that she used. And I'm abbreviating definition DEF in apostrophe. Okay, definition of supplementary angles. All right, continuing to look on down the line, we have at least two statements where the combination of those two statements adds up to 180. So if you have two math statements where they combine to equal the same thing, then they might as well equal each other. And so it's not specifically mentioned here, but it is. It's right here. We have supplementary angles being used. We have two things that are equal. Let's see. Oops, I have it here. Substitution. I wrote the wrong thing, and I wrote in pen, so you'll see it on my screen when I show you what I'm writing. If they're equal to the same thing, then that's the substitution property. Now, I wrote it down here on that page 307. I wrote bicongruent supplement theorem, but in the statements of what she used, I mean, she's literally using, okay, get a freeze frame of that. She's literally using given, same side interior angles theorem, linear pair postulate, definition of supplementary angles, and the substitution property, except the fact that we have this congruent supplements theorem card. So maybe I wrote it down, and I want you to write it down, but I want you to know that we can take two of these things away and just combine them together. We can take definition of supplementary angles, which I think is mentioned. Nope, it just says linear pair. And we can take out substitution property, and we can, instead of writing those two statements, we can just write congruent supplements theorem, because that's what the congruent supplements theorem is. Congruent supplements theorem. Like, instead of writing definition of supplementary angles and the substitution property, we could just say congruent supplement theorem. If two angles are supplements of the same, or a congruent angle, then those angles are also congruent. And that's found on page 291, page 294, and now on page 307. Okay? So those were the things that Abellina used. Let's go ahead and talk then about what Madison used, and then we'll do this video in two parts. So Madison has a similar structure. Madison does also use the given, right? She says, given the situation where two lines are parallel and they're cut by a transversal. Again, transversal being our vocab word. So there's definitely a given statement, but now what we need to do is identify, like she says, lines are parallel, angle 2 and angle 6 are congruent, and we go, why would that be the case? Well, it's because we know angle 2 and angle 6 are corresponding. And so if angle 2 and angle 6 are corresponding, then there's a whole host of stuff that we get to use from that. But Madison, as we write down her list of things that she used the given, she used corresponding angles theorem. And I see that in the pink. Corresponding angles theorem. Okay, then the next thing that she used, she says that angle 2 and angle 3 are congruent. We should know angle 2 and angle 3 are congruent because they are vertical angles. I mean, that's another vocab word. These two seem to be very entrenched vocab words. And there's another vocab word, correspond, right? When lines are parallel, then the angles that open the same way are corresponding. Turns out angle 2 and angle 3 are vertical angles. So that's another reason, a theorem that she used. We're going to write that down in question 1. Vertical angles theorem. And I'm running out of space to write all of my things. Last of all, if angle 3 and angle 6 are both congruent to angle 2. Kind of how one angle is congruent to another, then they must be congruent to each other. That's the transitive property. And I've got that written down in pink on page 307. I wrote down by the transitive property here. So if you didn't, like I said, get page 307 notes taken care of, please do. I'll go ahead and share with you what I'm writing down on page 308. This is a page 308 video. Transitive property. We're going to do question 2 and 3 in their own videos, just to keep things a little bit more short, so that you don't have to watch so much. But Abellina, this is everything that she used along the way. Madison, this is everything that Madison used along the way. And really, if you had followed along, or I'm sure you did, but I'm saying, like, in using the paragraph proof that's provided, we can tease out all of these statements that were used by each of these students. Thank you for watching this part of the 308 video. Go ahead and click forward to the next one, part B, where we do the flowchart proof for Madison's proof plan. Thanks again for watching. See you in the next video.